So go to the next slide.
Lake Tahoe. 39 trillion gallons of water that sits between the border of California and Nevada. This majestic lake is perfect for boating, camping, and playing in the sun. The lake brings in over $300 million annually. 50,000 residents call the area home, but over 3 million visitors come every year to see the clear, beautiful water. But all this beauty doesn't keep it safe for trout. Luckily, we have water managers on the job, who sure love water. But in order to measure the water, they have to travel out to aid stations, most likely using private jets. It's packed to the brim with stewardesses and fancy cocktails, which waste tax dollars, making us taxpayers sad. With these concerns in mind, our team began work on a tool that allows water managers to measure lake levels while barely lifting a finger. Our team partnered with the United States government to come up with a moniker for our tool that is both fun and catchy. The Lake Level Automated Monitoring Algorithm, or LLAMA for short. This name purely expresses the functionality of our tool while eliminating any possibility for it to be called anything other than LLAMA. Rather than using gauge stations of the past, LLAMA utilizes the power of satellites to see how a lake is changing from space. At 700 kilometers above Earth, the Landsat program has been collecting imagery at a 30-meter spatial resolution since 1984. And because of its position in orbit, each satellite will pass over every 16 days, and LLAMA will take a new measurement. I know what you're going to say. Won't all these images take up a lot of space on my computer? Of course not. LLAMA harnesses the power of Google Earth Engine. Earth Engine is a cloud-based geospatial software, so there's no need to clutter your computer with up-to-date satellite imagery. This also makes it possible for LLAMA to operate well into the future and monitor your lakes without you needing to lift a finger. Using the power of Google Earth Engine, our tool can handle anything we throw at it. This is our four-stage method of monitoring lakes. First, we locate the body of water using geographical polygons. Next, we put the lake through our four-stage water detector. Third, we calculate lake watershed and outlet content. And finally, we condense all the data into easy-to-read tables and graphs for your viewing pleasure. In order to locate the lake in question, LLAMA uses geographic data from a constantly updated Google 3D. This table is automatically accessed from within the code. It contains over 3,700 lakes at present. All you need to do is select a lake, and LLAMA will begin a 4-step process of water detection and water measurement. Step 1 calculates the modified normalized difference water index. This involves some simple math using the green and shortwave infrared bands, and assigns water lake pixels a high value, making them more likely to be classified as water. Step 2 finds dark pixels in the image. Water is very dark in the non-visible band, so if a pixel in the image is dark, it is more likely that LLAMA will classify it as water. Step 3 looks for brightness in the blue band. While water is very dark, it does tend to be slightly lighter in the blue band than it does in other Landsat bands. So if it's brighter in blue, it may be counted as water. Step 4 involves temperature. Landsat's thermal-based band measures the land surface temperature. LLAMA verifies that a pixel is above freezing before it will count it as water to make sure that snow doesn't get included in the measurement. With all these steps combined, LLAMA accurately detects water and calculates lake area. Here is a completed image produced by LLAMA with all the water it found highlighted. You can't hide from us, crafty water. Additionally, LLAMA can display images with allocated activity indices applied, so you can find all that dirty water in a pinch. But does it really work, you ask? Yes. Early tests are showing strong correlations between lake area and in-situ gauge measurements across Lake Tahoe, the Salton Sea, and Mono Lake. In short, LLAMA has shown itself to be an effective tool for monitoring lake changes in lake level over time. LLAMA's use of Google Earth Engine also demonstrates the power of cloud-based geospatial computing and shows that it can be a useful tool in environmental remote sensing given a reliable broadband connection, of course. With the LLAMA, your water monitoring woes are a thing of the past, because when you speak, NASA listens.